Let us see what I can explain more about nodes. You see this plane system here. Obviously that is plane. And let's now activate the creation mode and more precisely the creation of nodes. I just maximize this view, XZ view here, so then we can see more. And I will open now the context menu for this node here at the top right, double click. So the context menu is opened, and you see quite a lot of tabs here at the top. I'll just go to the most left here, that's the leading one. So here you see quite a few information about the principal context. Yeah, we can deactivate it, we can activate it, and all these things. Let's edit it now. It's not so important. Let's go to Geo. Here you see everything about the position of this node in space with the X, Y, and Z coordinates. And you see also some predefined values which are interesting with respect to the reference geometry and the cutting pattern in the context of form finding. For each of the nodes you have 6 degrees of freedom, 3 with respect to displacement components, U aligned to X, V aligned to Y, and W aligned to the Z coordinate direction. And we have the 3 rotational degree of freedoms, phi X, phi Y, and phi Z, the rotation angle around the 3 axes. Then we can also decide to have one or the other degree of freedom to be supported. Let's do an example. If I just decide the U degree of freedom to be supported, and we just save the input, you see highlighted now the support, the sign for the support condition as it should be. Just take it away and save again. Or let's look at the rotational degree phi y as an example here. So the rotation around the phi axis, which is just the axis coming out of the screen, and then this square is just the information for the rotation constrained around the phi y the y-axis. That's another example. The rotation around the x-axis would look like this. That would be the support sign highlighting the axis around which we have this constraint. Let's take away the supports and proceed. Then loads, I think that is also self-explaining. We have here a load in Z direction. Don't forget that Z is going downward in our notations. The moment around the y-axis would look like this, as we're just familiar with that. So a moment around the x-axis will be displayed here with a double arrow, as well as the moment around the z-axis combined with the moment around the phi-axis, just this inclined arrow, or just taking away the mx and also the fz here. No. So we have just left the mz, the double arrow for indicating the moment around the z-axis. Then, going back to the geo here, the coordinates, you may have asked what are these here. These are the rotation angles. If we just go double click in one of these cells here, in these fields, this submenu will be opened. And here we can just decide about what should be local definitions of displacement, things like that. So what I have chosen now is just the local system of element number 1. That should be this horizontal one. That's the element number 1. Or element number 3. That's the vertical one. That is this one here. And you see, the local definitions of the coordinates are just switched. The local x coordinate of an element is just aligned to the orientation of the element. Quite obviously, that's the first node. That's why where the x-axis is just starting, and it's just pointing to the second element. We may, of course, also handish just rotate these coordinate systems. For instance, just by giving the angles here for the rotations around the x, y, and z axis of the global system, we can just align all every orientation what we prefer with respect to the problem at hand. Completely flexible. Or if we just go back to the global orientation of our problem, so the local elements, local coordinate system is just disappearing. So that's also coming together with geo information. And if we now apply load, perhaps I give another example here, choosing phi equal to 3, and we now come to the point, what is the load fx? Now you see the load is aligned to this local orientation. Also, we have now the possibility, even if there is a local coordinate system defined, just to give in the load instead of locally, globally. Then you see that the load is just oriented along the global system, top left, rather than to the definition of the local coordinate system at that node. Also, we can just align that to our elements. So here the local x direction aligns to the global one, or we just choose the coordinate system of element number 3, and just prefer to have this local, the definition. Then the the load in x direction will be that one here, as we just have defined the local orientation. Now come on, so that's how it's supposed to be. So, and we can now here orientate the whole thing with respect to the definition of the elements, or keep it globally, and then it keeps to be global no matter how we just choose the local coordinate system, or we can switch back into the local orientation if we would like to do that. Okay, let's take away the loads here. Everything fine. And let's proceed here with our table here. So that's the top disp. Here we recover the displacement components after analysis. The displacement components u, v, and w again aligned to x, y, and z, either globally, like now, or in the local directions. And this will be the rotations around the x, y, and z direction, either globally as now, or if there's indicated a local coordinate system around along the local definitions. Eventually, if you think of pre-stress by pre-deformation, you can just give in here this pre-stress, these pre-deformations as it is the case in your problem at hand. Then on this tab we can see all the attached elements. We can also highlight them if we choose it from there. We can deselect all of them or select all, so depending on what we want to know. Then the question, what is a double node? I will come back to this when we talk about hinges in elements. I'll just refer to the tutorial about elements and hinges. There we will need double nodes. Then we have here this tab with all the erection forces. Of course, for that we need support here. If we just go to the next node here, node number 3, then you see eventually here for this completely clamped node we may expect reaction loads, reaction forces, or reaction moments in x, y, and z direction or around the related axes. The next one will be springs. So I'll just go back to node number 2. We can define spring stiffnesses with respect to the x, y, and z direction, respectively the u, v, and w displacement. So just typing in the spring stiffness and just saving the information. So you see here the displacement spring, the deformation spring. Or if we just would like to have a rotational spring, something like this. Now come on, for the rotation around the phi axis, take it away here. Or another example here, the rotation around the x-axis, then it would look like that. So you just see this rotational spring from the side, which does not make sense in that view, but if you just minimize the view, then you see the consequences here for the other views, or here in 3D, how these rotational springs are just aligned. Okay, coming back to our node, I again open the context menu and just take away the spring stiffness so that we are back to the node without any modifications. What remains is the drop-down menu what we have for the node. So if you just go with the cursor on the node, push the right button of our mouse, and then we see the drop-down menu for the node, which is in this case pretty small. We can close it again, this menu. We can edit the node if we like to. Then we go back to our node context menu, or we can make it invisible eventually, which is not possible if the adjacent elements are visible. Or we can delete the node, which is only possible if this node is free. So this node is not free because it's attached to the neighboring elements, so it's not possible to delete a node. So that would be the case with this drop-down menu. Okay, this drop-down menus, they just change their appearance just depending on the modes where we are. We just have been in the create mode. If we go to the select mode, so you see it's even smaller. In this case we can only close the menu again. We can edit the node and we can make it invisible, but as you see it's not possible to delete the node eventually. That's exactly the idea of this fail-safe select mode. So if we go to the animation mode, that's after analysis, then again this drop-down menu looks a little bit different. So we could also take a look at the support forces if there are some. So these drop-down menus are completely case dependent on the respective mode. We'll come to that later on, also in the context of Form Finder, for instance. Then these drop-down menus will have even more and different appearances. Okay, so much about what we can learn about nodes. See you later. Thanks.